A couple things to review before we get started today. If I had x squared minus 6x plus, let's make that a little bit smaller, minus 2x plus 9, does that factor? Two numbers that multiply to be 9 and add to be negative 2 doesn't exist. So we need to use a quadratic formula. 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 9 is 36, over 2 times 1 is 2. That would be 2 plus or minus the square root of negative 22 over 2. If we factor tree 22, what are the factors of 22? 2 and 11, can I pull out anything out? Nope, except for the I. So the answer would be 2 plus or minus I root 22 over 2. Can I simplify with the 2? No, not on the inside, only if it's on the outside. So if it was 2 root 22, then I could pull a 2 out. Okay, what about this? Let's put a 2 out here. I multiply 2 times 5 is 10. Are there factors of 10 that add to be 10? No, doesn't work. So 10 plus or minus the square root of 100 minus 4 times 5 is 20 times 2 is 40 over 2a, which would be 4. That is 10 plus or minus the square root of 60 over 4. And we factor tree 60, 10 and 6, 2 and 5, 3 and 2. I can take out a pair of 2's with a 15 left over. So 10 plus or minus 2 root 15 over 4. Now I can cancel out a 2, and I get 5 plus or minus the square root of 15 over 2. Yes, the only way to simplify is if all 3 of these have a 2. And you cannot touch the inside of the square root, because it's not really a 15. It's the square root of 15. So you might say that there's a 3 and a 5 in there, but there's actually the square root of 3 and the square root of 5, which they don't have any factors. Okay, one other way to really easily simplify the square root of 60, which numbers can square root? What numbers square root? 1, can you think of any others? 4, 9, 16. What are these numbers? They're perfect squares. So basically what we're doing, and everybody watch this, does 60 have any perfect squares in it? 1 isn't going to do us any good, but does 4 go into 60? Yes, 15 times. So basically we're saying the square root of 4 times the square root of 15, and that becomes a 2. That's what the factor tree does for us. So if I had the square root of 75, are there any perfect squares in there? 25. And 75 is 25 times 3. So it's like saying the square root of 25 times the square root of 3, which is 5 root 3. So when we simplify square roots, all we're doing is pulling out the perfect squares. If I had 72, that's the square root of 36 times the square root of 2, which is 6 root 2. If I had the square root of 18, what would that be? 9 root 2. If I had the square root of 30, 3 root 2, sorry. 30 is made up of 2 times 3 times 5. There's no square root in there, or there's no perfect square. 4 doesn't work, 9 doesn't work, 16 doesn't work, 25 doesn't work, so that one doesn't simplify. And that's basically what we were doing here. We're pulling out the perfect square and then leaving the remainder on the inside. And why did we want to do it? Because in the end, that 2 simplified. So you probably were wondering at some point, why do we simplify square roots if they're equal? Well, there's always a chance for further simplification if you pull something out. Okay. What if I had x to the 4th minus 6x squared minus 16? Does that factor? Yeah. X squared minus, nope, x squared minus 8 and x squared plus 2. I just treat it like a quadratic. Are there two numbers that multiply to be negative 16 and add to be negative 6? Negative 8 and 2, but instead of x minus 8 and x plus 2, it's x squared minus 8 and x squared plus 2. This one factors kind of in a weird way. It would be x minus, not 4, not 2, the square root of 8 and x plus the square root of 8. Does this one factor? No, because why isn't it x minus root 2 and x plus root 2? It's a positive 2. So it has to be a difference of perfect squares. The sum of perfect squares doesn't factor. Today, next time we meet it will. But right now it doesn't factor. So we would just leave it like this. If it's, so it needs to be something times itself minus something times itself. So I guess if you had something like 8 minus 3, you could say that that is the square root of 8 minus the square root of 3 times the square root of 8 plus the square root of 3. But you won't ever see anything like that. So this would be an x squared or an x to the 4th or something like that. I mean, this is true, but you won't run into that. And obviously, if it was x plus 7, you're not going to factor it. It's already done. You're not going to say square root of x plus square root of 7. That just doesn't happen. You would factor it into, if you had an x to the 4th, you'd have an x squared plus something and an x squared minus something, and then the negative one will factor again. Probably. Okay. What if I had 3x to the 3rd plus x squared minus 38x plus 24? What are my possible roots? Where do I look to find my possible roots? We look at 24. So any number that goes into 24. 1, 2, 3, 4, 6, 8, 12, or 24. That's a big list. And do we have to worry about fractions in this one? Yes. So all of those numbers divided by 3 are the possibles. What's the easiest one to try? 1. How do we try 1? Add them all together. 3 plus 1 minus 38 plus 24 is not 0. How do we try negative 1? We change the signs on every other problem. So it would be 3 minus 1 plus or minus 38 minus 24. That didn't work. So 1 and negative 1 didn't work. What's the best way to choose how to guess? Graph it. The best guess is going to be given if you graph. So 3x to the 3rd plus x squared. Oops. So plus x squared minus 38x plus 24. And then we look. It looks like negative 4 and 3 both work. So let's try negative 4. We put negative 4 in the corner. 3, 1, negative 38, and 24. Drop the 3. Negative 12, negative 11, 44, 6, negative 24, and 0. Okay, now what? Now this is 3x squared minus 11x plus 6. How did I know it was x squared and not something else? I took an x to the third and I divided it by x plus 4, and x to the third divided by x is x squared. And once I have an x squared, all I need to do is factor. I use the box. 3x squared and 6, multiply those together, and I get 18x squared. Are there factors of 18 that add to be negative 11? What are they? Negative 9x and negative 2x. What does the top row share? 3x, and if I pull a 3x out, what do I have left? X minus 3, and if I take an x out of the first column, 2x. So what are my other two roots? I know that negative 4 works. 3 and what about this one? Would be 2 divided by 3. Does everybody understand that? Now, there's another way to do this. I knew that one of my other answers was 3, so let's just do synthetic division with 3 and see what happens. I put 3 in the corner, drop the 3, 3 times 3 is 9, 2, negative 2, negative 6, and 0. So there is one root. Here is another root. Where do I find root number 3? This is 3x minus 2. How do I know it's x to the first? Because this one was 3x squared and I divided by x, so now I have 3x. And if I set this equal to 0, I get 2 over 3. I don't care what method you use, but you're not allowed to claim a root as an answer just because it's on the calculator. When we take the test on this section, you have to show me that the division yields a 0, and then you have to create a simpler equation and then do synthetic division or factor it. Does that make sense? So whether you do synthetic division all the way to the end, or you do synthetic division until you get a quadratic and then you factor it, that will work. Now, what if this is not factorable? What do? We use the quadratic formula. If it's not factorable, then no number you plug in into synthetic division will work. If it doesn't factor, then you look at your calculator, it's going to hit at some nasty number, and that nasty number is not a fraction, and every fraction you try won't work. Okay? So, what if I had x equals 4, 2, and negative 1? How do I create a quadratic equation, or an x to the third equation? Well, I know the roots. Can you tell me what the factors are? There are 3 of them. X minus 4, x minus 2, and x plus 1. How do I multiply 3 binomials together at the same time? I don't know how to do it. Okay, there's probably a way to do it, but nobody does. What you do is this. Now, you guys are smart enough, you probably don't need a box anymore to multiply. Can you multiply that in your head? You're going to get x squared minus 2x and minus 4x, which gives you negative 6x plus 8. So x squared, and then you have a negative 2 and a negative 4 and a plus 8. Now I have to multiply that by x plus 1. This you probably can't do in your head. X to the third, you can use the box if you want, plus x squared minus 6x squared minus 6x plus 8x plus 8. X to the third minus 5x squared plus 2x plus 8. Is everybody okay with that? All right, what if I had negative 1, 2 plus the square root of 3? Well, anytime a square root shows up as a root, then we have two roots, and they're conjugates from each other. So if 2 plus the square root of 3 exists, then 2 minus the square root of 3 also exists. Otherwise, your coefficients will be square roots. Okay, can you remember that? So it says, write a polynomial of least degree that has a leading coefficient of 1 and the given zeros. So if your leading coefficient is a 1, then none of your answers are square roots. That's a guarantee. Well, that's not quite true. If none of your coefficients have square roots, then your roots can only have square roots if there are 2 of them, and they cancel each other out. So if 2 plus the square root of 3 exists, then 2 minus the square root of 3 exists. It'll still have a 1, because we don't have any fractions. So, what are my factors? X plus 1. Does everybody get why those are both negative? If we had that equal to x, we subtract the 2 and we subtract the root 3. Okay? And then the other one is x minus 2 plus the square root of 3. How should I multiply these together? Right, we want to do the square roots together because everything is going to cancel. All of the square roots are going to go away. Okay? So you always do this first. If you don't, it will work, but it's going to be really long and nasty, and you'll probably make a mistake. Okay? X squared minus 2x plus x root 3. Is everybody okay with that? Now I move on to the negative 2. Minus 2x plus 4 minus 2 root 3. Slide this over. Okay. What does this one give me? Minus x root 3. And this one? Plus 2 root 3. And that one? Minus the square root of 9. What happens when you do root 3 times root 3? The square roots cancel. Any square root times itself is the number inside. So this will be minus 9. Now what do you notice? Oh my gosh, I'm sorry. Minus 3. Thank you. And x root 3 cancels negative x root 3. Negative 2 root 3 cancels positive 2 root 3. And I have x squared, and I have 2 copies of negative 2x. And then I have a 4 and a negative 3, which is plus 1. Can you guys recreate that? Well, you know that all the square roots are going to go away. So this one will always cancel that one. And this one will always cancel that one. And this one is always just negative the stuff in the middle, on the inside, every single time. Yeah, so basically what you're doing is x minus 2 times x minus 2 with a negative 3 on the end. Do you guys see that? We don't need to do this multiplication because we're guaranteed that this multiplication is going to cancel it. So all you really need to do is the x minus 2 times the x minus 2 and this one times this one. So you can skip 4 of those multiplications because they're guaranteed to cancel. So you do x minus 2 times x minus 2, which is x squared minus 4x plus 4. And then you have to do the negative root 3 times the positive root 3, which is negative 3. And you end up with 4 minus 3 is 1. Are we done? Nope. I need to bring in the x plus 1. X to the third plus x squared minus 4x squared plus x, or plus minus 4x plus x plus x plus 1. So that gives me x to the third minus 3x squared minus 3x plus 1. And that's the final x to the third. All right. Okay. So your assignment is still 3.53 through 53 odd. You asked about number 39. So number 39, what are the possible roots? Plus or minus 1? 2. Oh, good. We could factor out a 2. Okay, so 4 times x to the third minus 5x plus 4. So the possible roots are plus or minus 1, plus or minus 2, plus or minus 4. Okay. Could 2 be one of the answers? Look at the graph. Can 2 be one of the answers? No. Can 4 plus or minus 4 be one of the answers? No. So 1 has to be the only rational answer. The other 2s will have square roots in them. So what do we do if we know that x equals 1 is one of the roots? We do synthetic division with 1, and then we'll end up with a quadratic. What do we know about that quadratic? It won't factor. You have to use the quadratic formula because we pulled out that 4, so none of the answers can be fractions. Right? Every answer is either a rational number, an integer, or an irrational number with a square root in it somewhere. All right. Good luck.